Hello, this is Ertan Taskin, and we are continuing to talk about how to feed in the live data into the digital twin that we created for the Golden Gate Bridge. In the last video, we left the subject on how to read in the live data and feed. And we will see that we can do this in different forms. And Once the data is collected, we can run the code again um, and see the response and the corresponding outputs. For that, the first application will be, in fact, both applications. We're going to talk two applications. Both applications are going to be on utilization of the Python codes. So I'm going to switch to the code just to give you an understanding on how to make use of it. All right. Now, currently, what you're seeing is the corresponding code. Apparently, what you see here, corresponding latitude and longitude information is provided by the code to collect the live data. And I'm going to collect data at every 5 minutes for the duration of 2 hours. When the code runs, it actually puts on a screen at each and every 5 minutes with the corresponding X and Y components. So I already ran that, and it's already completed. You can see the data, live data, for the 2 hour duration, and it's also saved into the CSV files. So the data is collected from this URL where the meteorological data is available as a live data, and corresponding latitude and longitude is given, right, by the code, and the wind speed and wind direction are collected. Apparently, we do some math here just to convert the speed into the X and Y components. So from then on, what we do is we actually go and um, read these files into the twin builder, and then run the twin in there. So let me go there. So yes, if you look at the screen here on the twin builder project, we have two data pairs right now. For each data pair, this is for the X component, and what we're going to have to do is bring the corresponding data set. And apparently I looked at different data sets before, so what am I going to do? I'm going to go and import a new data set. And you will see that I have to change the format into CSV file, and then um, what you will see that there is actually a good feature of this code where it puts the timing, a date, as well as the collected time. So this is today's date, and between 11:25 to 13:25 the data is collected. So, and this is the X component. What we're going to do, so once we read the data, we're going to select the done, and it's okay. We will do the same thing for the second pair, the Y component of the data, and follow the same procedure. Let's pick this one. We have the data already with the time versus the velocity, and there you go. Okay, so once we have this already, when we hit the analyze button, it's going to read this data from those tables, and we're going to see the feedback immediately on the screen. As I said, this is one way of doing this, but what you can imagine, of course, there is a minimum 2-hour delay to get the response. Well, I collect 2 hours data. If you collect 1 hour data, then it's going to be a corresponding delay, of course. But there's another way of doing this, really, and we're going to go to that one right now. So the second method will be this time it's going to be live, but we're going to switch from the Twin Builder environment to the Python environment, and it's going to be a new Python code. But for that, we need to create a new twin file, which Python code will use the twin file, and then again, it's going to collect the data from the same place. And then on your screen you will see your outputs. Of course, you can save this also for each and every time point, like for example at every 5 minutes for the x and y velocities are put here, and the corresponding information on the bridge and the surfaces or so. So let's go this through one of my pre-recorded videos. So we're going to go to the subscript, and what we're going to do, we're going to select the module where considering the inputs and outputs. Now, as you see, if we take a look at this, the twin is already not visible. It was just like that, right? But that is actually currently a twin model. So what we're going to do, we're going to save it as the twin model, and then continue from there. So here is the corresponding Python code. Again, this Python code reads in the twin model that we saved, and also reads in the live data, similar to the previous code, and then feeds that as an input, and get the outputs and put it on the screen, as well as save it as a file. So when I started, this is my initial time point where the x and y components of the velocities are these, and with these the initial calculations are shown here, and it's going to be also saved in a separate file, such as created with the time stamp as well as the date of it. Once it's complete, you have the data already available, again in the CSV format. So this concludes the Golden Gate Bridge digital twin application. So we went through, we started from CFD to create the model, and created the reduced order model, and then bringing that into Twin Builder, creating a Twin Builder project, and feeding that project with the data. First, we explored how to put a constant and as well as a data set, and then reading the live data, either first reading it and saving it to a CSV file, and then making the Twin Builder model work on that, or create a twin model, extract that from the Twin Builder, and then put it into a separate Python code, and read, utilizing that, and read the live data, and collect the results immediately. Thank you for watching.